For today's lesson, we are going to learn about special right triangles. In geometry, there are two different special right triangles. There's a 30-60-90 and a 45-45-90. Those represent the angle measures of the triangle. And so our learning targets for today are for you to be able to say, I can find the side lengths of a 30-60-90 special right triangle, and I can find the side lengths of a 45-45-90 special right triangle. And more specifically, we are going to be working with a very special ratio that all of these triangles share. So for example, we have in a 45-45-90 triangle, the hypotenuse is going to be the square root of 2 times as long as each leg. So what happened is mathematicians did the Pythagorean theorem over and over and over and over and over again with a 45-45-90 triangle. And what they noticed is that the legs, which we're going to call X, and in the 45-45-90 triangle, this is a isosceles right triangle, meaning that two of the sides are congruent to each other. They noticed that in a leg of a 45-45-90, to find the hypotenuse every single time, it was simply take the leg and times it by the square root of 2, and you'll have the hypotenuse. And that was the pattern that they noticed over and over and over again. And conversely, if we were to know what the hypotenuse is and we would want to find what one of the legs are, instead of multiplying by the square root of 2, you would simply divide by the square root of 2. So therefore, in a special 45-45-90 triangle, the extended ratio of the side lengths of a 45-45-90 is 1 to 1 to 2. And that means that the hypotenuse of any 45-45-90 triangle is simply the leg times the square root of 2. And the leg is going to be equal to the hypotenuse divided by the square root of 2. Now, whenever you divide by a square root, like what we have here, you need to make sure that you are careful. So I'm going to write the note, please be careful. And that's because we have a root in our bottom. If you ever have a radical in your denominator, that means that you'll need to rationalize the denominator by multiplying both the numerator and the denominator of that fraction by the radical that you want to get rid of. So these are the two formulas that I need you guys to know, study, and memorize. How the relationship between a leg and a hypotenuse. If you know the leg, how do you find the hypotenuse? If you know the hypotenuse, how do you find the leg? So let's go ahead and do a few examples of these. So looking at example number 1, letter A, I know what a leg is, and I know what the other leg is. That's 12 centimeters. So we want to find the length of the missing sides. And so one side is automatically going to be easier than the others. So these two are congruent to each other, they're equal. So now I just need to go from a leg to the hypotenuse. And to find the hypotenuse, we're simply going to take our leg and multiply it by the square root of 2. So my hypotenuse is going to be 12 times the square root of 2 centimeters. Let's go ahead and look at letter B. For letter B, I know the hypotenuse this time, but what I do not know is I do not know my legs. So if you know the hypotenuse and you want to find the leg, you take the hypotenuse and divide it by the square root of 2. So I'm going to take 6 square roots of 2 and divide it by the square root of 2. The square roots of 2 eliminate, leaving us with just the number 6. So that means that each of my legs are 6. Letters C and D are a little bit more intense, and that's because of the fact that in this problem, I know what the hypotenuse is, and I want to find my legs, so I'm still going to use that same step of dividing the hypotenuse by the square root of 2. But now I have a root in my denominator, a root in my bottom, and I need to get rid of that root. So I'm going to multiply both the numerator and the denominator by the square root of 2. What's going to happen is I now have 10 square roots of 2 divided by the square root of 4, because I'm just multiplying insiders times insiders. This becomes 10 square roots of 2 divided by 2, and I can simplify this further. 10 divided by 2 is 5. So this is 5 square roots of 2, and that's what each of my legs are. All right, let's go ahead and do the same exact type of problem over here with letter D. Letter D, I know the hypotenuse. I just don't know what my legs are. So to go from the hypotenuse to one of my legs, I'm going to divide by the square root of 2. So I'm going to take 12 divided by the square root of 2, and I've got a root in my denominator. So I need to rationalize that by multiplying both the numerator and the denominator by the square root of 2. So this becomes 12 times the square root of 2 divided by, and there's a trick. The trick is that the radical is going to go away. So if you go back to this previous example, we ended up with the square root of 4, which is just 2. So essentially, the shortcut is to recognize that whatever is left over in whatever is the radicand, that is going to be your denominator minus the radicand. So this is going to be simply 2. If you want to show the full steps of now you've got the square root of 4 and the square root of 4 is 2, you're welcome to do that as well. 12 divided by 2 is 6, and so each leg is 6 square roots of 2. So just to recap, in a 45, 45, 90 triangle, it has a formula, or there's a relationship between the leg and the hypotenuse. A hypotenuse is equal to a leg times the square root of 2, and a leg is equal to the hypotenuse divided by the square root of 2, and you'll need to make sure that you are careful and rationalize the denominator if necessary. Let's go ahead and talk about now our next type of special right triangle. So once again, this is special because what mathematicians found is that when they did the Pythagorean theorem over and over and over and over and over again with 30, 60, 90 triangles, a pattern occurred. And that pattern is that the hypotenuse is twice as long as the shorter leg. So the shorter leg is always the leg that is opposite of your 30-degree angle or your smallest angle. So that's what I'm going to write down right now. It is always this leg that is opposite of the 30-degree angle or the smallest angle. That's considered your shorter leg. So to go from our short leg to the hypotenuse, we simply take that short leg and times it by 2, and now we have our hypotenuse. Conversely, if you know the hypotenuse and you want to find your shorter leg, you simply divide by the square root of 2. So that is one relationship. The other relationship is, so the hypotenuse is twice as long as the shorter leg, and the longer leg, which the longer leg is always opposite of the 60-degree angle. So, and the longer leg is square root of 3 times as long as the shorter leg. So, if you know the short leg and you want to find the long leg, which the long leg is across from the 60-degree angle. So this is the short leg. This is the long leg. And this is the hypotenuse. To go from the short leg to the long leg, you simply multiply by the square root of 3. And conversely, if you know the long leg and you want to find the short leg, you're going to divide by the square root of 3. So these are all of our relationships. You have the relationship going from short to long. Short to hypotenuse. You're going to take the short and times it by 2. And if you know the hypotenuse and you want to find the short, you're going to divide by 2. The other is if you know the short leg and you want to find the long leg, you're going to take the short and multiply it by the square root of 3. If you know the long leg and you want to find the short leg, you're going to divide by the square root of 3. So this is it drawn out as an extended ratio. The extended ratios of the side lengths is 1 to the square root of 3 to 2. So what that means is that your hypotenuse is going to be equal to 2 times the shorter leg, and conversely, the short leg is equal to the hypotenuse divided by 2. The longer leg will be equal to the shorter leg times the square root of 3, and conversely, the short leg is equal to the long leg divided by the square root of 3. And once again, you're going to need to make sure that you are careful. Please be careful. You'll need to rationalize the denominator sometimes, not all the time, depends on the problem, but a lot of times you'll have to rationalize the denominator. Notice that everything is based on the short leg. So with these types of problems, you need to make sure that you find the short leg first. So you need to find the short leg first because everything is based on the short leg. Everything is based on it. So these are your formulas that I want you guys to please make sure that you know, study, and memorize. Hypotenuse is equal to 2 times the short leg. Short is hypotenuse divided by 2. The long leg is equal to the short leg times the square root of 3. Short is equal to the long divided by the square root of 3, and you need to be careful. And once again, you need to find the short leg first. All right, so let's go ahead and do a few of these examples. So looking at example letter A, we want to find the length of our missing side, and what I know is I know the side that is across from the 30-degree angle. 2 is the short leg. And I want to find my long leg and the hypotenuse. So to go from the easy one, in my opinion, is to go from the short to the hypotenuse. All you're doing is multiplying by 2. 2 times 2 is 4. So the hypotenuse is equal to 4. And to go from the short to the long leg, we multiply by the square root of 3. So our long leg is simply going to be 2 square roots of 3. And that's all the work that you need to show. Show me what you're doing to the short to get to the hypotenuse and the short to get to the long. Let's go ahead and look at letter B. For letter B, I know the side that is opposite of the 60-degree angle. That means that I know the long leg, and I absolutely need to find the short leg first, and that is right across from the 30-degree angle. So over here is the short leg. So to go from our long leg to our short leg, we're going to divide by the square root of 3. So I'm going to take 5 square roots of 3 and divide it by the square root of 3. The square root of 3 will cancel away, simply leaving us with 5. So our short leg is 5. Now that we know the short leg, we need to find the long leg. We need to find the hypotenuse by multiplying by 2. 5 times 2 is 10. So the number 10 is going to be equal to our hypotenuse. Letter C. Once again, we know our long leg, and we need to find our short leg first. So to go from long to short, we're going to divide once again by the square root of 3. So I'm going to take 10 divided by the square root of 3. And now I have a root in my bottom in which I need to rationalize that denominator by multiplying both the numerator and the denominator by the square root of 3. This becomes 10 square roots of 3 over 3 using that shortcut I previously discussed. And now I'm going to write 10 square roots of 3 over 3. There's nothing to simplify here, and that's simply my short leg. Now to go from my short leg to my hypotenuse, I need to multiply by 2. And I'm going to show the work for this because I know that that can be kind of tricky sometimes for some students. So I'm going to take 10 square roots of 3 over 3, and I'm going to multiply it by 2. So remember that this is a 2 over 1, and we are multiplying straight across. So my denominator is going to remain 3, and over here I'm going to multiply just the 10 by 2, and that's because it's outsiders times outsiders. 10 times 2 is 20, so this is 20 square roots of 3. So my answer is 20 square roots of 3 over 3. And one thing that I need you to know is that sometimes you might have to simplify the radical further. And if that's the case, you always want to look for the largest perfect square factor that is inside or underneath the radical and then bring that out. So all of these answers need to be in simplified radical form. Let's go ahead and look at example number 3. In example number 3, it says, you make a guitar pick that resembles an equilateral triangle. So I'm going to draw an equilateral triangle. And some things you need to know about an equilateral triangle. First of all sides are congruent and all angles are congruent. They are all 60 degrees. So every single one of them are 60 degrees. So you make a guitar pick that resembles an equilateral triangle with side lengths of 32 millimeters. So I am going to label this 32 millimeters, 32 millimeters, and 32 millimeters. What is the approximate height of the guitar pick? So here is my height. I'm going to call it H, and I'm going to put a right angle symbol to indicate that this is my height. So there's a few things that I need you guys to know. First of all, whenever you drop a perpendicular inside of an equilateral triangle, what ends up happening is that the base ends up being cut in half into two congruent pieces. So half of 32 is actually 16. So both sides are going to be 16 millimeters. Not only is the base cut in half, but also the angles are cut in half as well. So this angle right here, half of 60 is 30. So both of these are 30 degrees. So now if you look really closely, how are we going to find our height? Well, what we have right here is a 90-degree angle, but more specifically, it is a special right triangle. So here's 60 degrees. This is 32 millimeters. Here's my right angle symbol. I'm calling this H for height, and this is 16 millimeters. And that's right across from that 30-degree angle. So we can just work with our special right triangles, our patterns, to help us to identify what our height is. And this is the long leg. 16 is the short leg because it's right across from the 30-degree angle. And 32 is our hypotenuse. So to go from our short leg to our long leg, we're simply going to multiply by the square root of 3, making H equal to 16 times the square root of 3 millimeters. And there's your answer. There's your height. There's more drawing to that problem than actual math to show. Final example, we have a car is turned off while the windshield wipers are moving. The 24-inch windshield wipers stop, making a 60-degree angle with the bottom of the windshield. So if you can imagine windshield wipers that are moving, and they form a 60-degree angle. The wipers are 24 inches. So here is a 24-inch windshield wiper. How far from the bottom of the windshield are the ends of the wipers? So I'm going to drop a perpendicular, and we want to find out what this height is. So I'm going to call it X. You can call it H if you want. That's fine as well. So because this is a special right triangle, I know what the hypotenuse is. I just don't know what the height is. And since it's across from the 60-degree angle, this is actually the long side. And what we need to find is we need to find what the short side is first. Once you know what the short side is, then you can find the long side. So I'm going to go from the hypotenuse to the short side by dividing by 2. Half of 24 is 12, so this is 12 inches. Then from there, now that I know my short, I'm going to find my long side by multiplying by the square root of 3. So my long side, or how far from the bottom of the windshield are the ends of the wipers? Well, X is simply going to be 12 times the square root of 3 inches. And there's your answer. As well as the end of today's lesson. If you have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.